Our next speaker has come all the way from South Africa, where they do things at a big scale, I believe. We've been on the receiving end of your rugby teams.
We don't go there.
Yeah.
No.
So I'll hand you over now to Trevor Wilson from Working on Fire. Trevor.
Good morning, folks. It's just still morning. Just make sure this is working. All right. That was better. Push the button. Okay. We don't talk about rugby. No. Or cricket. My name is Trevor Wilson, and I represent the Working on Fire International team, and we are global practitioners of integrated fire management solutions, and we love fire. We live, eat, and sleep fire. We've got 9,000 people across the world, all the way from the east, all the way to the west, from Chile, all the way through to Indonesia and Australia. And the best part about having a global footprint is that there's one thing that does not change across the entire world. Fire is exactly the same. The fuels are slightly different, and the politics are very different. And the people are exactly the same. A firefighter is a firefighter, doesn't matter where you go. It's the same thing. And the Indonesians have a saying, it's same, just a little bit different. So I'm going to be presenting on behalf of my colleague, Bob Connolly, who is in Brazil now, working on an operational plan for 1 million hectares of prescribed burning. I wish I was there instead, but don't worry. So let's have a look. Fire is a relatively simple science. It really is. It's the triangle. And there's one thing on the fire triangle that can be influenced before the fire. Only one. Because you can't change weather, you can't change oxygen before the fire. There's one thing you can change, and that's the fuel. And that science makes it very easy. Because if fire is a science, then putting out a fire is a science, then preventing fire is a science, and then using fire is a science. Because an unnatural buildup of fire fuel loading is going to be a recipe for disaster. We've got operations in Chile, my son is there, and what has happened in Chile has been directly related on the most with fuel loading. Just too much fuel on the urban interface. Too much fuel building up to commercial forestry. Too much fuel across a massive landscape, and it has had catastrophic consequences. The urban interface is not going to change. We aren't going to wake up tomorrow morning and suddenly find people not wanting to live in the mountains, not wanting to live in the forests, not wanting to live in the high fuel load, open savanna grasslands. That's not going to change. So what are we going to do? Because that fuel is going to be there. And if that fuel is not mitigated, it'll just take the wrong day at the wrong time with the right ignition, and that's it. It'll be a catastrophic event. And that's not being horrible or being pessimistic. It's a fact. Too much fuel is catastrophic. It has catastrophic effects. And we strongly advocate, and we use, because we come from a fire endemic or a fire adapted environment, we strongly use fire to fight fire, scientifically, and that's the caveat. Here's a sequence of photographs that has happened. This is Cape Town, South Africa, the last 2 weeks. And I'm sure you've all seen thousands of photographs like this. This is nothing unusual, but look at the urban interface. Look at the fire behavior. Look at the fire is meant to be there. It's the people that have got in the way. The people are just in the wrong place, in the wrong situation, at the wrong time. But it gets worse. This is Chile over the from the 15th. The day to look out for here is the 26th. Watch what happens. There's the 20th, 21st, 22nd. Watch what happens down near Concepcion, which is just above the 7 there. 25, bang. You know what happened there? It moved into commercial forestry. The moment it hit commercial forestry, that was it. It was done. And fortunately, they had a slight wind change, and things have now quietened down, and they are getting it under control. But fuel is directly related. And I hate showing these sort of pictures, because this is not something that should be normal. This is not something that should be acceptable, and, it happens every 10 years. Why? It doesn't have to happen every 10 years. We've all seen, on a micro level, what fuel does to fire behavior. And it makes fire devils, and it rips trees out of the ground. Both of those pictures there are directly fuel related. Yes, it was dry. The picture on the left, there was no wind. So you can't blame the wind for that fire. Purely fuel. So we use aircraft and aerial ignition for our prescribed burning. And one of the biggest reasons why we use aircraft is that it gives us time. Anybody who's operational knows that when you are doing prescribed burning, you run out of time. You try and start in the cool, or you try and start in the warm part of the day. All depends what you're going to do. And there are not enough hours to be able to pull enough lines to be able to do as much as you need to do by hand. And because we have moved from small scale prescribed burning to very large scale, we needed to move faster. And we use the Australian rain dance system, which uses little capsules of potassium permanganate injected with glycol, and it's a very controlled environment, and we drop them out of both rotary helicopters and also fixed wings. Because we can manipulate the fires and the way the fires burn by the way we put the capsules down. Exactly the same way as if you've got a drip torch and you're doing it by hand, and you pull the lines close or you pull them further apart. It's going to do something different. We can burn into wind, out of wind, downwind, everything, every single scenario that you can do with a drip torch, you can do with an aerial ignition, but faster and over a much larger area. So we do high intensity burns, low intensity burns, environmental burns. We do under canopy burns. You can burn straight through pine trees. I'll show you pictures of that now. That's really good fun. We do fire breaks as in any fuel reduction along a lateral or on a linear basis. We'll go into more detail. Open-ended fire breaks, I'll explain that. Patchwork or mosaic burns. And then high altitude or difficult access burns. Places where you would have to walk for 5 hours to get to the top of the hill. We fly there in 30 seconds. And then fire suppression. We use it as an active fire suppression tool with parallel and with indirect attack. As I said, the biggest thing is time, but it's also safety. We don't have to have any firefighters in the area that we are going with. Imagine 50,000 hectares of high intensity burn. You could not put anybody in there. We have to chase elephants away and rhinos away, and we chase the animals out. We don't want to chase firefighters out as well. And we have a very, very controlled position to be able to control the ignition speed, the ignition sequence, and what the fire does to the microclimate. Fires change the climate. We can change it back by manipulating how we pull that fire on a large scale. The biggest thing is time. We can make a very small time window be very productive and let nature put the fire out. For example, if you need to burn from 2 o'clock until 4 o'clock, because at 4 o'clock the humidity starts climbing, temperature starts dropping. At that cross, you want your fire to be the biggest if you're doing a large area. You can time that to the minute because you can see and you've got the big picture. And then as the temperature drops, humidity starts climbing, the fire starts dying. Intensity starts coming down, nightfall comes, dew drops in, fire is out. Dumb deal. We can control that. So for example, with a manual, if we were doing understory burning, we could maybe do 100 hectares per day. We can do over 1,500 with an aerial ignition. Block burns, as in mosaic burns, 2,000 hectares a day, plus or minus 20,000 if we are doing aerial. Remote access, not a problem. And fire breaks by hand, 3 to 5 kilometers, versus aerial ignition where we do 10 to 60 kilometers. And that's 60 kilometers of 500 meters wide we can burn in one day. because we just pull with the aircraft. The biggest thing, I'm not going to go through all of this, is planning. Every single fire has got the same science, and it's got the same things that we want to get out of, but what are those things? Do you need a hot burn for environmental biodiversity, or do you need a cold burn or cool burn just to get rid of the top 2-inch level, duff level? If it's not planned, we don't do it. We don't touch it. Because you can imagine doing a 20,000 hectare burn without a plan would be rather silly. But there's a reason why you often hear operational firefighters say this is a very good idea. And they say, brilliant, we want to do it. And then you hear the managers say, whoa, stop. It's because the managers haven't got their hands on the feel. Every single fire talks to you. It tells you what it's going to do, and you can manipulate it. One of the biggest things that we have to do in this room is to let the managers, or to educate the managers, to understand what it feels like, what it smells like, and what it sounds like. This is an example. Every single fire has a test fire, and we use the humidity spike to see when it's going to start slowing down. So on this fire, it was at 1600 hours, 82%, the fire started dying, and we then knew what window we had, and we used that window afterwards. Under canopy, yes, it's safer, everything is good. This is what it looks like. That there is 26 tons of fuel per hectare on the ground in Pinus Eliotia. You would think that that would be impossible. It's not. Because it would be impossible if you do it at 2 o'clock in the afternoon. But how about you do it at 5 o'clock in the afternoon, when the weather is going to offset the fuel load and the fuel moisture? You manipulate it with the weather, because we all know what the science looks like. We've got models, scientific models that have been proven, whereby we can burn that safely underneath those trees, and mortality is not an issue. There's one that's a lot easier. Am I running out of time? Okay. This is a lot easier, and you're just wanting to get rid of that top layer to stop that, or to slow that fire down, to be able to give us more time to put it out. Very cool, no damage to the standing trees. Exactly what you guys are doing here. Exactly the same. In fact, that picture there could be in Spain. It isn't. It's the same, but different. Research and development is critical. Every fire has got slight things that have got changes. What are those changes? Why did it change? Write it down, work out why, understand the science, and then use it practically. We also have fun with spiral ignitions. This is where you start the ignition in the middle and you start moving out with a helicopter. And basically what you do, you manipulate the fire to make your own convection column. Once you've made your own convection column, you can manipulate where the fire goes. You can move it around. You can actually make it walk. It's great fun. This is how you would burn a green area very hot, because you manipulate the fire to make it hot without the fuel, or you can go the other way as well. High intensity, lots of large areas. Let's get some pictures and have some good ones. That there is the start of 50,000 hectares burning. It's in savanna grasslands. We needed it to be very hot to take down the bush encroachment. The trees were starting to get closed canopy, so we burnt. You see right in the far side there's a little fire. That little fire is the test fire for this. We got the test fire in, and then we just pulled. And there's 50,000 hectares about to go bang. There's some more under the head. We monitored the entire area the whole time. Actually, what I was doing there was chasing rhinos away. The rhinos were in the way. Yes, we did move them. That's what it looks like inside there. This was wanted. We really did need this to be like that. It's great fun. Open-ended fire breaks. It's a Western Australian concept that we've also played with. And what you do with this one is that you take a very inaccessible area on a ridge, and you start the fire, obviously with aerial ignition, on the ridge, and let the fire go down. But when you start it is critical, because you want that humidity spike and the temperature drop. So here, for example, we did 64 kilometers on top of a very high mountain range in 44 minutes. And we sat there and we watched it, And by sunset, you started seeing the fires going out until it was dark. 64 kilometers done. This is a strategic fire break between Lesotho and South Africa. We also paint pictures with fire. This is a picture of an eland on the left-hand side and a little kid playing with it. We love fire. It's a science and it's an art, and we like doing it. Gracias.
Thank you, Trevor. We have room for one very quick question. Nothing too technical.
If it's technical, catch me afterwards.
Any takers for a question? One question.
Hola.
Hola.
Bueno, yo quería preguntarle si realmente es algo efectivo hacer tanta superficie de quema cuando lo que se intenta evitar precisamente es evitar grandes incendios, ¿no? No sé hasta qué punto, como no manejo las dimensiones que tienen allí en este país, imagino que eso será porque las superficies son exageradas, ¿no? Para que tengan que hacer unas quemas tan grandes para controlar ese tipo de incendios. O a lo mejor lo que hacen es en diferente época, como no sé si lo ha dicho, creo que no. Imagino que lo hacen en invierno cuando sea más húmedo para que cuando en verano suceda lo tengan más fácil de controlar, ¿no? Esa es la duda que me ha quedado. No sé si es por diferente época del año y por qué tanta superficie, sería la pregunta.
Thank you for your question. It's a little bit complex in the answer, but to make it easy, a lot of those large fires were strategic fire breaks between countries. So, for example, one was between the Mountain Kingdom, one was between Mozambique, because we can't have wildfires crossing international boundaries. And a 100-meter fire break won't work, because our fires spot 5,000 meters, no problem. So we have very, very wide areas. But it's not only fire breaks, it's also for biocontrol, as in for bush encroachment, environmental burns, burning to sweeten the grazing. There are about 15 different reasons why we burn. But if you want to meet afterwards, I can show you all the things. Thank you.
Thank you.
That's it. Gracias.